Today we're going to talk about standardized scores, and z-scores are the main type that we will talk about in our discussion. This is chapter 5 in your book, of course. The purposes of z-scores, or any standardized scores really, are that it tells the exact location of each z-score, of each score, raw score in the distribution. So if you have a raw score, say, of 73, and it is a distribution that has a mean of 70 and a standard deviation of 3, that is telling us we have a z-score of 1, and that tells you that you have a score that is exactly 1 standard deviation above the mean, a score of 73. It is a z-score of 1, and that score of 73 is exactly 1 standard deviation above the mean. On the other hand, if you had a score of 76, and we're still looking at the A diagram here, with a mean of 70 and a standard deviation of 3, a raw score or an X score of 76 gives us a pretty extreme score that is actually 2 standard deviations above the mean. And on the other hand, if you had a distribution with a standard deviation of 12, a very large spread of scores, even though the mean is still 70, that score of 76 is not extreme anymore. It's just a half a standard deviation above the mean. So a z-score of 0.5 or 1/2. And that just tells you that it's not that extreme of a score. So we can also use these scores for direct comparison to other distributions that have been transformed. And this is just what we're talking about here in diagram A and B. We are comparing a score of 76 on distribution A, which gives us a z-score of 2, which says I'm way above the mean. We're comparing that with distribution B with a standard deviation of 12, same mean of 70, and this time my score of 76 is just a half a standard deviation above the mean, or a z-score of 0.5. So transforming is just relabeling. So the location and distribution. The sign tells whether the score is above or below the mean. So a positive 1 or a +1 z-score means it is 1 standard deviation above the mean. A z-score of -1 means it is 1 standard deviation below the mean.